Okay, so I'm going to go over my IQE number 2, which is a conduction problem. So in this problem, we have a car on a cold day, 0 degrees Fahrenheit on the outside, and someone turns on the heat inside their car. So the inside of the car is at 65 degrees Fahrenheit. And what we're trying to solve for here is the temperature of the glass 4 centimeters from the inside, considering that this is a 5 centimeter thick piece of glass. And the things that we know in this problem are the thermal conductivity, the generation term, and then those 2 different temperatures. So how we're going to solve this problem is we're going to start with the general term, or the general equation for something like this when it relates to heat flux. And there's going to be no change in the temperature in the z direction or the y direction. This is just going to be an x-related problem. So from there, we can integrate once, and then we have to find our C1 and C2 constants. We can apply that boundary condition of at the x position equals 0, that temperature is T1, which is going to be 65 degrees. And then at T2, that x position is going to be the L, or the length of the glass, and it's going to be 0 degrees. So eventually we can solve for our temperature profile by plugging in some things for those constants. We had to convert our temperatures into from Fahrenheit to Celsius, just for the units of the problem. And using those ideas, we can solve for that temperature at the 4 centimeter mark by plugging in our different values. And the conceptual question in this problem is to provide a general graph of the temperature versus position. And so since there's a heat generation term, the temperature is going to start at 65 degrees, it's going to move upwards, and then it's going to move downwards, so that final temperature of 0 degrees. So it's going to be a graph like what's shown here, with that concave down kind of shape. So that's pretty much what is going on in this problem.